Hello, yes. We welcome you back to PSSB, Physical Sciences, Silver Bullet, and Richard here. Yes, now this is our next approach on this topic, momentum, and we are looking at change in momentum. Yeah, we have to remember that momentum is the product of mass times velocity. So it means that if momentum is going to change, one of the two variables can change. Mass can change or velocity can change. But in most of the cases we are going to look at, almost 99.9% of all the cases we are going to see, the change in momentum is going to be brought about by change in velocity. And if we are taking that one as the case, this is what we have to remember, that if you have delta means change. So if the change in momentum is delta p, then change in momentum is going to be p final minus p initial. You have to recall that every p is equal to mv. So in other words, if you substitute for the p, f, and pi, this is what you're going to get. That change in momentum is going to be m v f minus m v I. And that one is going to be our traditional equation for change in momentum. But like I told you before, when you go beyond this level, you are going to see that at times mass can be the one changing. But for simplicity, all our cases are going to be a situation where it's the velocity which is changing to bring up the change in momentum. So if you look at this one, let us define each of the terms we have here. Delta P is change in momentum. Given in which units? In a kilogram meters per second. Okay. Then M is mass, given in kilograms. Vf is final velocity, given in meters per second. And Vi is initial velocity, also given in meters per second. So there we are. Now I need to tell you that the changes which you are going to experience here, they are going to be under this category. First, we are going to look at changes when they during slowing down. Slowing down, meaning that the final velocity is going to be smaller than the initial velocity. We are going to look at another change which involves the speeding up. Where the final velocity is bigger than the initial velocity. We are going to be another one which involves change in direction. Where the direction of the velocity changes. And we are going to look at a case from each of this one and one example from each of this case so that we can get used to that. Yes, there we are. This is one example of slowing down. The question says that a bullet of mass 10 grams is fired from a rifle, passes through a thick door, and its velocity reduced from 450 to 250 east. So the bullet, when its velocity is reducing but maintaining the same direction. Yeah, then the question says, calculate the change in momentum. Okay, how do you go about this? This is what you have to know. We already know the equation. The equation says change in momentum is equal to mvf minus mvi. Okay, after that, what's the next step? Is to look for these variables. We are looking for change in momentum, so we don't know it. But we know mass. The mass of the bullet is 10 grams. And that's not SI unit. So what do? You change it to kilograms by dividing it with 1000. And you get 0.01 kg. Okay, that's that. Next, we need final velocity. And final velocity is 250 meters per second. Next, you have the initial velocity, which is 450 meters per second. From there, what do we do next? What you do next is to substitute. Every information is there. So what are you going to say? Change in momentum is going to be equal to, what's the mass? The mass is 0.01. Okay, times what? Times final, which is 250, minus 0.01 times 450. And what you get out of that is going to be our change in momentum. So our answer is -2. The units are kilogram meters per second. Now the question at hand is, what is the implication of negative? Negative means opposite direction to the initial direction. So we are going to say 2.00 kilogram meters per second. In what direction? Initially it was east. This one is going to be west. So our change in momentum is in opposite direction to the initial direction. Yeah. Then the next question says, draw a labeled diagram indicating the final momentum, the initial momentum, and the change in momentum. Okay. The approach to this question, the best approach is this one. You have to come back to our equation, which is delta P is equal to mvf minus mvi. And from here, you have to use to find those values. If I can recall, this was -2. Okay. Let us see. This was 0.01 times final velocity, which was 250. And this one was 0.01 times 450. Let us get those values. Okay. Yeah, then we come here. We have our change in momentum as -2. And you have our PF. Remember, whatever you have here is PF. And whatever you have here is PI. So our PF is positive 2.5. And our PI is positive 4. 0.5. Now there's a trick which you have to know, that when you add these two numbers, the magnitude exempting the signs, you get this. So pi is obtained by adding these two. That one helps you to know which one is the biggest vector. Look at here. The biggest vector is 4.5 and is pi. So suppose I have that one as my pi. And now I'm going to come and represent this. But you have to remember something here, that the two vectors which are coming, when you add them together, they are going to be equal to this big one. So in other words, these two vectors are going to fit between here, but with their respective directions. Okay, let us look at that one. What is our PF? Our PF is positive also, and you indicate it that way. I'm taking to the right as positive. So this is our PF. So this gap we have here is for our delta P, and it is negative. So you have it there, but you change the direction. This is the best way to represent vector diagrams. I would urge you to drop whatever you are seeing somewhere. This representation has two important information it gives. First of all, it gives you the direction, okay, which other vector diagrams are giving. But secondly, it brings out the idea that when these two vectors are added, they'll give up that one. And that information is missing in other representations, which most of the books put across. And with that, we are going to cut this video here. We thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet. See you next time. Don't forget to subscribe. Don't forget to like. We are simply the best.